Okay, so I will give you a few minutes to write this down. Please let me know when you are done writing this stuff at the beginning. So scale factors, this is the fun term that we're using. Scale factors are used when you are talking about similarity, okay? They tell us how much bigger or how much smaller the second item is. Okay, I'm gonna write that down actually. I'm gonna put that here. So, how much bigger or smaller the second triangle actually is. So we're kind of answering their question like by how much? How much bigger is it? Is it 10 times bigger? Is it 3 times bigger? We're looking at or smaller. Is it half the size? Is it a third? Is it a quarter? Is it only 10%? Like how much smaller, how much bigger is it actually? And the goal of the scale factor, okay, is using the information from one of the triangles in order to get information about the other triangle. That's kind of the goal here. And we're working with triangles because triangles are easy. They only have 3 angles. It's usually quite straightforward to be able to determine which is which, like what's happening there. Okay. A simple example of a scale factor is what we would see on a map. Okay, so you know at the bottom of maps, there are scales. It'll tell you 1 centimeter on this map actually represents 600 meters or something along those lines. Okay, we could use a ruler to find the distance between 2 cities on a map, but then we would multiply using our scale factor to determine the actual distance between those 2 cities. So that is how the scale factor can be of use to us because it allows us to take something really small and then multiply it to determine a much bigger or a much smaller thing, depending on what we are looking at. Okay, I'm just going to scroll down here. I'm not going to go too far, so a lot of things are still going to be on the screen, but let's talk about how to find the scale factor. So to find the scale factor, there are basically 2 steps. The first step is that we are going to match up the sides with each other. And sometimes it helps to redraw the shapes, especially if they've been rotated, especially if they are not as easy to identify which ones are the same and which ones are not. So let's do this for this first example. I have 2 triangles here, and okay, I'll stop. I'll wait a minute. I'll wait a minute, and then you can tell me when you're ready to go. I'll wait a minute. So you tell me when we're ready to do the example together. Okay, we have an hour left of class, and for today, we're going to explain, we're going to be looking at golf, but because we're at home, because you don't have equipment at home,
you are going to be having a quiz on the like fitness aspect of the course.
Are we doing still need more time to write this stuff down? We done? Okay, my heck's good. We still need a little bit more time. Okay, I'm gonna do I'll wait another minute and then we'll keep going with this first example here. We're done. Okay, maybe we'll get started right now. Okay, so we have our first example. We have two triangles. I have triangle ABC, and we've been provided with the side lengths. We know that we have a side length of 10, of 6, and of 7. We also know that DEF is the second triangle, 20, 12, and 14. Okay, now just based on looking at this triangle, can somebody suggest for me in the chat, can you give me a pair of sides, just like we saw before the break, a pair of sides that are going to be similar to one another? B, E, those are those are angles. So we know that B and E match up with each other because they're both doubles. Good. I'm looking for sides specifically, a side length. So remember, we write side length. So for example, I am looking at side AB. What would side AB match with? Good, DE. AB is going to match with DE. Yeah, that's okay. No problem. No problem. AB is going to match with DE. We know that for sure. And if we wanted to just double check, we could say, well, look, I go from a single loop to a double loop, just like I go from a single loop to a double loop. It's pretty easy on this one because it's all straight up and down. It's already aligned, but I promise you I'm going to give you one that's all spun around and it's going to be different. Okay. Now, the second step here, so we can match up the sides with each other. Let's do that. Can somebody give me another one? Another pair that are going to be the same. I'm going to color code them. So we know that those two are similar. Can you give me another pair of sides that are going to be similar? Those are angles. Remember, we're looking for sides. AC matches with DF. Good, awesome. AC matches with DF. Let's put those guys in pink. So AC down here matches with DF. Yep, great job. Okay, and then that leaves us with our third one here, that BC matches with EF. Awesome. Awesome, awesome, awesome. Let's do that gray and orange. Okay, so we have these things that are matched up. So now we can compare nice and easy. So that is always the first step, is to match up sides with one another. Our second step, we have to divide the larger side by the smaller side. Okay, so let's deal with our first example here, where we have AB matches with DE. What is bigger, 10 or 20? 20. Obviously, 20 is bigger. So we're going to say, okay, 20 divided by 10. We're going to do, let me just color code that. Big divided by small. Okay, what about the next one for AC and DF? Can somebody tell me the equation that it's going to be? Try again, a little typo there. 14 divided by 7. Good, we're going to do 14 divided by 7. You got this. Okay, I'm just going to, let me just highlight this in the pink. So this is this guy, and we're going to go 14 divided by 7. And then what's the last one going to be? What is that last equation going to be? 12 divided by 6. Y'all be killing it. Good. So we're going to take our orange line. We're going to go 12 divided by 6. Okay. Let's actually do this math, shall we? What is 20 divided by 10? 22. What is 14 divided by 7? 14 divided by 7. It's also 2. Gee, I wonder what the last one's going to be. What is 12 divided by 6? It's also 2. Good. 2, 2, 2, 2, 2, 2, 2, 2, 2. Exactly, exactly. So we have now a scale factor of 2. That is the answer to this question. If we wanted to write this in a sentence, I'm going to write it just under here. I don't have a ton of room, so I'm going to write it really small. I can say triangle DEF is 2 times as large as triangle ABC. And we use that scale factor of 2 for telling us how much bigger, or in this case, how much smaller it is. Okay. Let's go down to our second example here. And what I'm going to challenge you to do is to do this, everything that we just did, just on your own. Okay, and then there's a third example that we are going to do together. So first things first, step number 1, match up the sides with each other. Okay, that's what we did here. We matched up the sides with one another. I said what side matches with what. And then I divided the larger side by the smaller side to determine my scale factor. Okay, I'm going to leave this here. I'm going to give you 10 minutes to do this, and then we are going to take it up. Okay, I'll be here. I'm just going to turn off my camera, but I'll be here while you're working on that.
since after generation, so they use big sweater, roll up your sweater, put a sweater on the ground, when the ball cancel through your sweater, you have to put the ball on the sweater over or without the
Okay, we'll do 2 more minutes and then we'll take it up here, folks. Okay, folks, does anybody want to take a stab at sharing their responses or just any part of the way? Maybe you want to tell me which sides match with which ones? That would be great. So what are some of our sides that match up here? Which sides match with which? Okay, 25 and 20 match up. Sick. Let's do that one. So we have 25 down here, matches with 20 down here. Okay, perfect. And that equation, remember we always do big divided by small. So we're going to do 25. Oh, that's way too small. Let me make this a little bigger. We're going to do 25 divided by 20. Perfect. Okay. We know that, oh, it says 20 and 18. You want to try again there, Nishan? 20 and 16 match up. Good. 20 and 16. I think there was just a bit of a typo there. So 20 and 16. So these guys match up. Perfect. 20 and 16. So we'll do, and then that'll be 20 divided by 16. Yep, perfect. Okay. And then we are left with our leftovers here. We have, let's do this yellow. 22 is then going to match with 18. Perfect. So we're going to have then, I'll do this across. 22 divided by 18. Okay. And we can actually go ahead and calculate all of that. Did anybody find out the scale factor? What did you get? Let's do it together. What if one side doesn't match? Then that means that they're not similar, but they all should match here. But that would mean that they're not similar. Yeah. So I did 25 divided by 20 and I got 1.25. If I then do 20 divided by 16, I also get 1.25. And then last but not least, I'm going to do 22 divided by 18. Oh, yeah, you're right. That one's off by a little bit, eh? It's 1.2. Oh, man, I wonder what it should be. Hold on for a second here. Oh, it's because it had to be rounded. Okay. Okay, so instead of 18, let's do 17.6. My bad, guys. It must have rounded it. Let's pretend it's 1.25, shall we? 1.25. So we have a scale factor of 1.25. And so we know we can say, we don't have a name for this triangle because we don't have any vertices, but we could say something like the bigger triangle is 1.25 times larger than the smaller one. Okay, thanks for pointing that out. I'm gonna have to fix this diagram for next time. Man, as an aside, I've used this question like many times before, and this is the first time this has come up. So kudos to you for finding that for me. Okay, we're gonna do one more where I've spun it around on you. Okay, so we have here, we have two triangles. They're similar triangles. However, the problem is that they have been spun around. So I'm going to go back to the advice that I gave you at the beginning-ish of this lesson. You can always find matching sides by looking at the loops of the angles. Okay, so if we have a single loop and a triple loop, that's one side. Well, where can I find a single loop and a triple loop on my smaller triangle? So I have a single loop and a triple loop. Oh, you guys are probably writing down the triangle. Okay, I'll give you a minute. I'll give you a minute to draw the triangle and then we'll start talking. Okay, so I'm going to get started here. So whenever we don't know, I'm going to write a little note and a little like thought bubble over here. So I'm going to say if matching sides is not obvious, use the angles to help. For example, one loop to three loops on both triangles will match. So there's my little thought bubble off to the side here. So if we can't figure it out because they have been spun around because they are totally, totally different, we are going to use the angles to help. So in the first example that I was giving was between a single loop and a triple loop. So I'm just going to highlight that baby. Let's do this one. Light purple. Okay, single loop to triple loop. Can somebody tell me what my single loop to triple loop side is on the smaller triangle? So here I have a single loop to triple loop. Try again, Suhana. P is involved. P does have a single, but I need a triple. I need 3 loops. CE to PB. Awesome. We're going to come down here. Those guys are going to match. Good. Good, good, good. Awesome. Oh, yeah, the letters are right beside each other. No problem. So let's write that out. In this case, 18 is our bigger number. So I'm going to do 18 divided by 12. Awesome. Can somebody else suggest matching side lengths for me? Which ones match? CR and HP. Excellent. Nice, Mustafa. Nice. So CR is a 1 loop to a double loop. That's good. So we're going to go 1 loop to double loop. That matches there. Perfect. And so we're going to do, in this case, 12. Yeah, divided by 5. I think that should be different. Okay, and then last but not least, RE and HB. Good. RE and HB. And so that is going to be 10 divided by 8. Okay, let's do the math on these ones, shall we? 18 divided by 12 is 1.5. 12 divided by 5 is 2.4. And then we have 10 divided by 8. Well, that's 1.25. None of the numbers are the same here. So what does that mean? Does anybody remember what did I say? What does that mean if the numbers don't match up? Hey, great idea. We're not going to find the average. No, we're not going to find the average. But good idea. Good idea. You want to find the middle ground. I appreciate that. That's a good idea. It means that these are not similar triangles. Plot twist. These are not similar triangles because there's no way, there's no one single number that each of those pairs matches up with at the end of the day. Okay, so I'm going to put a little conclusion here. These are all different. So the 2 triangles are not similar. Yes, you're right. You're right, Azad. It's not a plot twist when you you saw it coming. You saw me coming, giving you a trick here. Yeah, so that's how we check. If we have, just highlight this. If we have 3 different numbers that are coming up here, or even if one is different, then they are not similar triangles at the end of the day. Awesome. Okay, great work here. So we were talking about the scale factor. The scale factor allows us to determine how much bigger or how much smaller 2 triangles are. I'm going to just stop the recording here.